Sorry about that. All right, so chapter 6 is the inequalities chapter. Inequality chapter is what chapter 6 is. Now, inequality is an expression that does not have an equal sign. Okay? But instead of an equal sign, it has 4 other possible symbols. Y'all know what they are? Less than, greater than, less than or equal to, or greater than or equal to. Okay? So instead of working equations, we're going to be doing inequalities this chapter. So our answer should contain one of those symbols. We should not be putting equal signs with our answers, okay? Our answers are going to be a range of numbers, not just one exact specific number, okay? So something else, we're going to graph them on a number line. When we graph our numbers on our number line to show the answer, to show the solutions, when we have a less than or a greater than, we're going to have an open circle at that number. That means that number is not included in the answer because it doesn't say or equal to. If it's less than or equal to or greater than or equal to, we're going to put a closed circle. That means that number is included in the range of solutions. So here's a few examples right here. The first one is graph x is less than 3. So I want you to draw a number line. It doesn't have to be a big number line. Put 3 in the middle. So I don't care that, some teachers are mean and want you to put like 10 numbers on a number line. That's not my style. 3 is enough for me, okay? So we're going to show on this number line all the numbers that are less than 3. Okay, so 3 is my boundary. Does 3 get an open circle or a closed circle? Open, because it's just less than. So that means it's a boundary for these numbers, but it's not included. So if it's open on the line, that means it's not included. And which way do we shade to show numbers that are less than 3? To the left. So the numbers that are less than 3 will be to the left of 3. And something easy to notice about that is that whichever direction your symbol points, that's which way your arrow should point also. So that's how we graph x is less than 3 on a number line. So let's do the same thing for x is greater than or equal to -1. Draw yourself a little number line. Remember, negative numbers go backwards, right? The further left a number is, the lower it is. Remember, negatives go backwards. So -1 is our boundary number. Does it get an open circle or a closed circle? Closed, because we're including -1 in our answer. It gets to be part of the answer. And which way do we shade? To the right to say greater than or equal to. So make sure when you darken it that I can tell which side is supposed to be the dark side. The dark side. So any questions about how we graph an inequality? Okay, so this time it's a little backwards. This time they give us the inequality and we have to write the expression. Okay? So to start it out with, you're going to have a variable, whatever variable you like. And what's the boundary number? 4. And what symbol do you think goes in between? Less than or equal to. Why is it or equal to? Because the 4 is included. It's closed in. So that means it has to be equal to. It's going to the left, so that needs to be less than. So is everybody okay with why this one is x is less than or equal to 4? Okay. So now we actually get to solve some. And y'all, we solve inequalities just like we solved equations back in chapter 3 when we first started this algebra stuff. Okay? You want to do the inverse operations to move numbers to the other side away from the variable. And remember, what you do to one side, you have to do to the other side. All right? So the only difference here is we're going to have inequality symbols instead of equal signs. So X minus 7 is less than 8. How do you think we're going to get x by itself? Add 7 to both sides. So x is less than 15. So x can be any number that is less than 15. Can x equal 15? No, because it just says less than 15. And it says to graph my solution, and that means on a number line. So draw, that's very crooked number line. So draw yourself a line. Put 15 on there. And then 16 is above it. 14 is below it. Does 15 get an open circle or a closed circle? Open. And which way do we shade for less than? To the left. Less than goes left. Double L. Yep, double L. Less than goes left. Is that hard? Didn't think so. It's a good Monday lesson, right? It's really easy. All right. But I'll take an easy lesson any day of the week. All right. M minus 9 is less than or equal to 3. How do we solve it for M? Add the 9 to both sides. So M is less than or equal to what? 12. And we draw our number line. Stick a 12 in the middle. 11 and then 13. Why did that so up high? Does 12 get an open circle or a closed circle? Closed. And which way do we shade? Left or right? Left. We darken the left side. Mine's crooked. Any questions? Look at E and write that down. E is wrong-sided, right? What do I mean by wrong-sided? The variable's not on the left, it's on the right side, right? So all we have to do is get the variable by itself. But inequalities, the order does matter. You do need it variable, inequality symbol, number. It's got to be in that order. So we're going to go ahead and solve it for x like it is, and then we'll swap it around at the end. So how do we get x by itself? Subtract 7. What is 9 minus 7? So I have 2 is greater than or equal to x. But we cannot leave an inequality symbol like this. We have to have the variable in front. So if we rearrange it so that the variable is in front, what else do you think we have to do? Yeah, we got to make the symbol read the other way also. Because look, if you read this one says 2 is greater than or equal to x, and x is less than or equal to 2. So we got to make it say x is less than or equal to 2. So when we rearrange it so the variable comes first, make sure you flip your symbol. It keeps the or equal to, but we got to flip the direction. Does that make sense to everybody? All right. So it still says the same thing even though it's written in the other direction. So number line, 1, 2, 3. These are all less thans. Looky there. So far. So does 2 get an open circle or a closed circle? Closed. And do I shade left or right? Oops. And darken it. Yes, I did put a decimal on there on number F just to show us what we're going to do there. So it says M minus 3.8 is greater than negative 1. So how do we get M by itself? Add the 3.8. What's negative 1 plus 3.8? 2.8. So M is greater than 2.8. How are we going to put this on a number line? You could. Or 2.8 is in between what two whole numbers? 2 and 3. So if you want to, stick 2 and 3 on there. Is it closer to the 2 or closer to the 3? You're in the middle. Yeah, 2.5 would be about right there. So 2.8 would be about right here. Right? Open, circle, or closed? Open. And which way do we go? To the right. So if you get a decimal or a fraction, I'm perfectly okay if you just put it between the two whole numbers it goes in between. Same thing with improper fractions. Does that make sense? So just estimate where they go. Just make sure you label your number line so I can tell what you're doing. Okay? All right, this next one gives you what we call a verbal expression. No, it's not. These are you tries. Y'all try those. There's a verbal expression coming. I do know that. Y'all try those. These. The next one's a verbal expression. Do the number line as well. This fibers are ugly. Let me fix that one. So what do we do on the first one to get m by itself? Add a half. What's -1 plus a half? A negative a half. Can I leave my answer in that direction though? We gotta flip everything. So m is what? Less than or equal to -1/2. And then on your number line, where is -1/2? Yes, and remember negatives go backwards and it's right in the middle. Does it get an open circle or a closed circle? Closed because it's or equal to, and less than shades where? Left. Raise your hand if yours looks like mine. Something close. All right. Number 2. How do we solve that one for y? Minus 5.5. So y is greater than what? A half of 0.5. Since they told me decimals, I can use decimals. And where is 0.5? Exactly between 0 and 1. And open circle or closed? And where do I shade for greater than? Right. So, guys, y'all have to know, without me telling you this is less than, this is greater than. Y'all know which one is which, don't you? Less than points left, and it kind of looks like an L. So there you go. 3 L's for less than. Okay? All right. Here's this verbal expression that I was talking about. Write the first sentence. You don't have to write the direction. The sum of x and 12 is at least -4. So what we're going to do is we're going to write the inequality and solve it and graph the solution like we've been doing. Something we need to talk about is at most and at least. You need to know these. And well, first of all, what do y'all think at least the symbol is? Greater than or equal to? Well, it says least in it. Wouldn't that be less than or equal to? Okay, right. So at least means that's the lowest possible number it could be, right? So for something to be at least, that means it needs to be greater than or equal to. Very good. So if I say, if you want to make an A in this class, then your average needs to be at least 93%, right? Technically 92.5 because it rounds up. Okay? So could I make a 92.0 and my grade be an A? No, it has to be greater than or equal to 93. If I make a 100, is my grade an A? Yes. So write these down and memorize them because people get them confused all the time, and you will see this on like quizzes and stuff. At least is greater than or equal to. At most is what? Less than or equal to. Okay, so that means it cannot exceed something. It can't get any bigger. So I'm going to highlight these because they're kind of important. So we're going to take that top sentence and make an inequality statement out of it, and then we're going to solve it. So the sum of x and 12. So what do you think we write for the sum of x and 12? Right, sum means to add. So we're going to say x plus 12. What do we use for at least? Greater than or equal to negative 4. And then we solve it for x. How do we do that? So x is greater than or equal to what? And on a number line, negative 16 goes in the middle, negative 17, negative 15. Y'all don't forget about negatives going backwards. And does negative 16 get an open circle or a closed circle? Closed. And which way do we shade? To the right. Any questions? Questions? All right, that is all section 6.1. So we are ready to move on to section 6.2. And y'all need to go ahead and write that rule down. So I'm going to pause for a second and let y'all get that rule written down for sure because it's important. Bless you. So all of them that we did in section 6.1, we had to solve using adding and subtracting. That was actually the name of the title of the lesson. So everything that we solved, we added or subtracted to both sides. These are also one-step inequalities. However, to get the solution, we're going to multiply or divide both sides. And the rule for this is when we multiply or divide both sides of an inequality by a negative number, and that's only for multiplication or division, you must flip your inequality symbol. So if it's less than, make it greater than, make it less than. Only when the number you do to both sides is a negative. Okay? So look at example A. It says x divided by -6 is less than or equal to 7. So how do you think we're going to get the x by itself? Multiply by -6. And am I multiplying both sides by a negative? Yes. So I will change this and make x is greater than or equal to -42. And just to save time on this section, I am not going to make us do the number lines this time. Okay? I showed you how to do it on the first section, so you know how to do it if you have directions on a test or something. But any questions about this? The number we multiplied on both sides was a negative. That's why we flip. Okay? The next one, x divided by 4 is less than -5. How do we solve that one for x? Multiply both sides by 4. So, are we flipping our sign? There's negative right there. Oh, that's not the one I multiplied on both sides, was it? Okay. So if the 4 had been negative, we would flip. But since the 4 is positive, we don't flip. And so x is less than what? -20. Very good. So the number you do on both sides has to be negative, and that's when you flip. Ooh, look at C. -39 is greater than or equal to -3x. So that's one of those backwards problems. So how do we get x by itself? Divide by -3. Am I going to flip? Yeah, I'm dividing by a negative on both sides. So what's -39 divided by -3? +13. And I'll flip my symbol. Less than or equal to x. But do I leave my inequalities backwards like that? Nope, variable has to come first. So what do I have to do here? Flip everything, right? X first, instead of less than or equal to, greater than or equal to, +13. So that one I had to flip twice. I would want to say you flip it because I'm telling you, I grade these quizzes every semester and people mess up on them trying to do it in their head. Okay? So y'all understand that, because if you put it that right there, it would be an incorrect statement. You can't put that one greater than or equal to right here because that would be incorrect. So all of our steps need to be mathematically correct. Does that make sense? Okay? So yes, our answer needs to be correct, but our work needs to be correct also. Okay? So, anyway, do you understand why we flip twice? First time we divided both sides by a negative, and then we cannot have our variable coming last, so that's why we flip again. All right, look at D. How do we get x by itself on problem D? Divide by -4. Are we going to flip it? And x is going to be less than what? A half. Not 0.5. There's a half. Only give me decimals when they give you decimals. This is supposed to have a division bar right here. Now that makes a little more sense. How do we solve this one for M? Do what? Do what? Yeah. The x is where it's supposed to be. Exactly. The x is where it's supposed to be. So I divided by a negative, I only flip once. You only flip twice if you divide by a negative and you have to move the variable. You're good. Okay. All right, so on problem E, how do we get M by itself? Multiply by -2 on both sides. So are we flipping on this step? Okay. So -2 times -14 is what? 28 is greater than or equal to m. So we flipped it there because we multiply both sides by a negative. Now what do? Flip everything to make it say m is less than or equal to. So you only flip twice if you have to move your variable and you multiply or divide by a negative. I was going to have, can we skip some U tries? All right, here's a word problem. It's not really a word problem. It's more, they call these verbal expressions. So it says the quotient of m and negative 4 is at most 28. The quotient of m and negative 4 is at most 28. What does quotient mean? It means we're going to divide. Do we say negative 4 divided by m or m divided by negative 4? Right, do it in the order they tell you, okay? So m, I don't know why I'm writing black. M over negative 4. What symbol do I put for at most? Less than or equal to 28. Are there any questions on how we have it set up? All right, so how do we get m by itself? Multiply by negative 4 on each side. Am I going to flip? Yes, so m is greater than or equal to what? Negative what? Sounds right. So any questions on a word problem like this? Verbal expression. All right, that's end of section 6.2. Now we get to put it all together in section 6.3. In case you're wondering, the official time is 8:37 a.m., so we have lots of time left. So we're going to put all the adding and subtracting and multiplying and dividing together here on this section. All right? And we're going to solve it, like I said, just like a regular equation, except for if we multiply or divide both sides by a negative number, we have to flip our symbol. And remember, we're not putting any equal signs with our answers. We've got to have an inequality symbol for our answer. Okay? So if you have an inequality problem on a test or a quiz and you put an equal sign, it is wrong. Okay? So problem A. 3x minus 7 is less than 8. How do you think we're going to get the x by itself? Add 7. There's our start. So 3x will be less than what? 15. And then how do we solve for x? Divide by 3. Do I flip? No. So x is less than what? 5. Any questions about that one? I think y'all hit the jackpot on easy lessons today. Right? Yeah. Wait till tomorrow. All right. So problem B, negative 7x plus 2 is less than negative 5. So how are we going to get our x by itself? Subtract 2. So negative 7x is less than what? Negative 7. And then how do we solve for just x? Divide by negative 7. So what do we have to do? Flip our symbol to greater than. And what's negative 7 divided by negative 7? 1. Any questions about that? Then our problems get to be more fun. One third parentheses 3x plus 6 is greater than or equal to negative 1. So we want to solve for x. So what do you think we're going to have to do first here? We can distribute this one. This one is a good one to distribute with the fraction because both of those numbers on the inside are divisible by 3, aren't they? Yeah, so multiplying times a third is the same as dividing by 3. If they were not divisible by 3, y'all remember the trick we did in chapter 3 to get rid of the fraction? Yeah, you multiply both sides by its reciprocal, right? So you multiply this by the reciprocal and they would cancel out, and multiply this by the reciprocal. Okay? But since they're both divisible by 3, I would go ahead and distribute it. So what is 3x times 1/3? 1x, right? Plus what's 1/3 times 6? 2 is greater than or equal to -1. Then what do? Subtract 2. So x is greater than or equal to -3. Any questions about that one? Okay, so on problem D, we have a variable on both sides of the inequality. So remember I told you when that happened, let's get our variables together first before we get stuff away from the variables. So how do you think we could get our variables together? Yeah, and on inequalities, it saves you a step if you go ahead and pull everything to the left. No matter what, if you pull everything to the left, it'll save you because remember we have to flip at the end if our variable's on the wrong side. So what's 9x minus 6x? So 3x plus 6 is less than or equal to 21. Then what do? Subtract 6. So 3x is less than or equal to what? 15. And then what do? Divide by 3 everywhere. Do we flip? X is less than or equal to what? 5. So any questions on those? Could you guys try these 3 real quick? On your own paper. Make sure we get the same thing. If you've got all three of them answered, go ahead and check with a neighbor. Symbols count. So if your symbol's wrong, it's wrong. All right, y'all look with me on number 1. What did y'all do first to get y by itself? Subtract the 5, right? And then I'm getting negative 6y is less than or equal to what? And then what do I do to get y by itself? And I divide by a negative, so I have to do what? Flip my symbol to greater than or equal to. What is negative 21 over negative 6 reduced to? They're both divisible by 3, right? So is that 7 over 2? 3.5, but I'd leave it like that. So raise your hand if you got y is greater than or equal to 7 over 2, or 3.5. Good job. Y'all, the symbol matters. If you said less than or equal to, that is wrong. That's totally wrong. There's a big difference in numbers that are greater than a number than numbers that are less than a number, right? So symbols are important. Don't say, but I got the number right. It's just equally wrong if you get the symbol wrong, okay? All right, so number 2. There's a couple ways you could have done number 2. Somebody tell me one way you did it first. Raise your hand if you distributed all the way through. Okay, raise your hand if you did the reciprocal thingy. Who did a reciprocal? Start off. You did? Okay. I'm gonna do it distributing all the way through, and then I'll go back and do reciprocal, okay? Okay. So what's negative 1/4 times P? Negative 1/4 P. What's negative 1/4 times a negative 12? Positive 3, right? Do I swap my symbol after I distribute? No, because when I did that, I multiplied it just to the left side, not on both sides, right? Okay, so when you distribute, you don't change symbols. So now how do we get P by itself? Subtract 3. So that's negative 1/4 P is greater than or equal to negative 5. And then how do I get rid of the negative 1/4? Multiply by the reciprocal, which is what? Negative 4 over 1, which is negative 4. Right? So now do I have to flip my symbol? And what's negative 5 times negative 4? Positive 20. And I swapped it to less than or equal to. Do I need to work that the other way for anybody? Does everybody understand? So when you do the reciprocal, it keeps the same sign, right? Opposite reciprocal is what we did with perpendicular lines. These aren't perpendicular lines, okay? So when you do your reciprocal, you have to use the same sign. So any questions about number 2? We all good? All right, number 3. Somebody tell me what you did first on number 3. Subtract 3x. So what is 5x minus 3x? Minus 12 is less than or equal to negative 4. Then what? Add 12 everywhere. So 2x is less than or equal to what? 8. And then what? Divide by 2. And x is less than or equal to what? 4. Raise your hand if you got that one right. Good. All right. Last few. Two more examples, guys, and maybe a you try. We'll see how it goes, and then we're done. So what do y'all think we're going to do first here on problem E? We're going to distribute. 14x plus 5 is less than 7, parentheses 2x minus 3. We're going to distribute the parentheses. So we're going to copy the left side. And what is 7 times 2x? 14x minus 30. Minus 21, right? I just did the most common mistake. You're supposed to do the outside term times both terms. Now, let's get our x's together. How do we get our x's together? We're already looking at it a little bit funny, aren't we? Why are we looking at it a little bit funny? All the variables are gone, right? They cancel out. They make 0. So write down what you're left with. You're left with 5 is less than negative. Is that true? A positive is less than a negative? Okay, is that true? Is a positive ever going to be less than a negative? No, it's not mathematically possible. So if your variables cancel out, all right, if they all go away, and you write down what's left, and it's a false statement, this is completely false, then you say no solution. If your variables cancel out and you're left with a false inequality, you say no solution. So you got to know a little bit of number sense to know which numbers are bigger than other numbers, right? And you got to be able to know that's a less than sign, not a greater than sign. Okay? So any questions about that? And those are nice because those are short, right? We didn't have to finish it out. So if your variables cancel out, if it's false, write no solution. So write down problem F. If you haven't already, 12 minus 1 is greater than 6 parentheses 2x minus 1. All right, so copy that 12x minus 1. What's 6 times 2x? 12x. What's 6 times negative 1? Negative 6. And we have the same thing with x's, so we know they're going to cancel out. Cancel, cancel. Now, if these are opposite signs, though, and I was having to add 12 to both sides, they wouldn't. So I like to go ahead and show that they cancel out because sometimes you think they're going to cancel out and they don't. This one's also false. That's crappy. You're right. Okay. True or false? That one is true. So, do y'all know what we're going to say if it's true? All real numbers. That's right. That means no matter what number I put in for x will be a true inequality. So if we have a false statement, we say no solution. If we have a true statement after our variables cancel out, we say all real numbers. So any questions about any of those? But we work it out like it's going to work. We just keep on working until something like this happens. So any questions about any of the lessons today? Okay.